Lesson 7.2, Properties of Parallelograms. A parallelogram is a quadrilateral, which means it's four sides, with the opposite sides parallel. So the definition of a parallelogram is the opposite sides are parallel. It's in the name. Parallelograms have sides that are parallel, such as this. You can see the opposite sides are parallel. We can prove then that the opposite sides are also congruent. And that the opposite angles are congruent. Also, in a parallelogram, the consecutive angles are supplementary. So, consecutive angles are like this angle and this angle, the angles that are next to each other. If the sides are parallel, then those angles are consecutive interior angles with parallel lines, which we've already learned are supplementary. That was in chapter 3. And the other property of parallelograms is the diagonals bisect each other, which means this is congruent to that, and that is congruent to that. The diagonals cut each other in half. Let's try an example. First of all, I'm telling you this is a parallelogram, which means the opposite sides are parallel. Find x, y, and z. Well, we could start with, actually, let's start with y. Y is the easiest one. Y is 42. Why is y 42? Because opposite sides of parallelogram are congruent. Oh, hey, the other easy one is z. Z is 20 degrees. Why are those angles congruent? Well, we have a parallel line and a parallel line and a transversal. So this is going back to chapter 3. Z and the 20 degrees are actually alternate interior angles. So Z is 20 because the alternate interior angles theorem, which leaves x. Well, up here in this, we know this one's 90 degrees, and we have the 20 degrees, and this angle is the same as x, because opposite angles of parallelogram are congruent. And if we use the triangle sum theorem, we know that the three angles in the triangle add up to 180. So x plus 90 plus 20 equals 180. So x is 70. Let's try another example. Find MN. All right, now I didn't tell you, but I'm telling you this is a parallelogram. So this is a parallelogram. All right, MN is part of the diagonal. So our theorem for diagonals of parallelograms is that diagonals of parallelograms bisect each other, which means that is congruent to that, which means MN is 2. Find measure of angle JML. JML is this whole angle. A lot of students want to say it's 60 because 30 and 30, but that's not right. If we ignore the diagonals and just look at angle KJM and JML, the two angles at the bottom, they are consecutive angles. So consecutive angles of parallelogram are, that's right, supplementary, which means the measure of angle KJM plus the measure of angle JML has to equal 180. Well, KJM is the 110 degree. So measure of angle JML is 70. So this whole angle there is 70. So what is the measure of angle KML? Well, that's just this half up here. So if the whole thing's 70 and we know part of it's 30, we could use we could add up our two angles. So we could say measure of angle KML plus measure of angle KMJ. So the two parts of this angle, just add those together, and they would have to equal the 70. So angle, small angle plus small angle equals big angle is the angle addition postulate from chapter 1. KMJ is 30 degrees. So measure angle KML is 40 degrees. Three vertices of a parallelogram are those. Maybe we should graph it. D is -1, 4. E is at 2, 3. F is at 4, -2. Now we need to find G. We could draw some lines here, some segments, I guess, actually is what they are. Now G is going to be somewhere in here. Just to figure out where. But remember, it's a parallelogram, which means the opposite sides are parallel, but also that the opposite sides are congruent. So the top, to go from E to D, we go up 1 and over 3. So from F to the other point, I'm going to do the same thing. We'll go up 1 over 3. So this is up 1 over 3, so I went up 1 over 3. So I'm thinking it should be right there. Well, let's check. From E to F, I'll go down 1, 2, 3, 4, 5, and over 2. Down 5 and over 2. So now from D to G, I should go down 5, 2, 4, 5, and over 2. Hey, that works. There we go. So where is G? G appears to be 1, -1. What we did is we just counted the opposite sides, I move the exact same distance to get the other point.